हेलो। हाँ, पिछले वीडियो में मैंने आप लोगों को बताया था वन डायमेंशनल हीट इक्वेशन का सलूशन। इस वीडियो में हम पार्शियल डिफरेंशियल इक्वेशन के अगले एप्लीकेशन पे जाते हैं एंड नाउ वी डिस्कस अबाउट वेव इक्वेशन। नाउ लेट अस कंसीडर ए क्वेश्चन इज ए स्ट्रिंग इज स्ट्रेच्ड and fastened to 2 points L apart. Motion is started by displacing the string into the form y equal to k Lx minus x square, from which it is released at time t equal to 0. Find the displacement of any point on the string at a distance of x from one end at time t. ये आपका क्वेश्चन है। स्ट्रिंग इट मीन्स एक थ्रेड आपका 2 पॉइंट पर बंधा हुआ है। एक एंड इसका दिस बी द ए एंड सेकेंड एंड दिस बी द बी। इस दो एंड के बीच में एक थ्रेड है, तो जो दोनों एंड हैं दैट इज़ द डिस्टेंस, दैट इज़ द यल इज़ द डिस्टेंस बिटवीन दीज 2 पॉइंट। थ्रेड आर फास्टेंड एंड स्ट्रेच्ड है एट ए पॉइंट ए एंड एट ए पॉइंट बी। 2 पॉइंटों पर बंधा हुआ है। इस स्ट्रिंग को आप डिस्प्लेसमेंट दे रहे हैं, तो जब स्ट्रिंग में आप डिस्प्लेसमेंट देते हैं तो वाइब्रेशन ऑफ द स्ट्रिंग एक वेव इक्वेशन के द्वारा दिया जाता है। सो इसका सॉल्यूशन इज द वाइब्रेशन of the string is given by del 2 of y is del t square is equal to c square del 2y of del x square. This will be the equation number 1. This is the first equation, that is the wave equation, where c be any constant. Since the string is tightened at the 2 point, so as the end point of the string are fixed for all time so y at 0 comma t, this will be 0, this will be the equation number 2, and y l comma t, this will be 0, this will be the second initial condition, this will be the equation number 3. Since the initial transverse velocity of any point of the string is 0, therefore del y over del t at t equal to 0 is 0. This will be the third initial condition, this will be equation number 4, and it is given when y x comma 0, this will be the k Lx minus of x square, this will be the equation number 5. These are 4 initial conditions from the given question. Since the ends are fastened between the 2 points, so वो fixed है, so initial condition is 0 comma t is 0 and l comma t is 0, and at a point A is 0 and at point B is 0. And initial transverse velocity of the string is 0, del y over del t at t equal to 0 is 0, and the fourth condition is yx comma 0 is 0. This condition is these four initial condition we have obtained the solution of this equation. And to obtain the solution of equation number 1, we use the method of separation of variable. So let the solution of equation 1 be the y is equal to x into t. This way equation number 6, where capital X and capital T are the function of x and t only respectively. It means capital X is the function of x only and capital T is the function of t only. So using equation 6 in equation 1 we have del 2 of x c square x del x square is equal to del 2 of t del t square. Using 6 in equation 1 we have this, and in this equation we have to use separation of variable since x is the function of x only and t is the function of t only, so we separate these variables in one side x only and in another side t only, and this be the equal to minus of k square we let. This be the equation number 7. Now we from the equation 7 we have हमारे पास इक्वेशन 7 से हो जाएगा c स्क्वायर del 2 of x over del x square, this be equal to minus of k square, and del 2 of t over t del t square, this be equal to minus of k square. So auxiliary equation for the above equation will be m square is equal to minus of k square upon c square. So m is equal to k by c plus minus I, and auxiliary equation for this will be m square is equal to minus of k square, so m will be plus minus of ki. Now the solution is capital X is equal to c1 cos of k by cx plus of c2 sin of k by cx, and from this capital T is c3 cos of k of t plus c4 sin of kt. So using these values of capital X and capital T in equation 6 we have y is equal to c1 cos of k by cx, c2 sin of k by cx into c3 cos of kt plus c4 sin of kt. This is the solution of equation 1. This is the solution of given wave equation first. ये wave equation का आपका solution हो गया. Now we have to given 4 initial condition, that is the y0 comma t is 0, yl comma t is 0, and derivative with respect to t is 0, and value of y at when t equal to 0. So using y0 comma t equal to 0 in above equation, we have 0 is equal to c1 c3 cos of kt c4 sin of kt. Since this is not equal to 0, so this implies that c1 is 0. So equation 8 becomes y of x comma t, this will be c2 sin of k by cx into c3 cos of kt plus c4 sin of kt. Now this will be the equation number 9. Now we put y0 l comma t is equal to 0 in above equation. We have 0 is equal to c2 sin of k by cl, c3 cos of kt, c4 sin of kt. Since this term will not equal to 0, and when c2 is 0, so the solution will be trivial. So this we cannot take this case. So this implies that sin of k by cl equal to 0. This will be equal to sin of n pi. This implies that k by cl is equal to n pi. So this implies that k is equal to n pi c by l. N pi c by l. This is the value of k. This will be the equation number 10. Now, to substitute condition third, we differentiate equation 9. Now differentiating equation 9 with respect to t, we have y x comma t del of del t, partial derivative with respect to t, c2 sin of k by cx minus of c3k sin of kt plus of k c4 cos of kt. Now put third initial condition del y over del t, this be 0 at t equal to 0. When we substitute this initial condition in above equation, we have this be the 0 is equal to c2 sin of k by cx into k of c4. This implies that c4 is equal to 0 because k is not equal to 0 and c2 sin k by cx is not equal to 0. So using c4 equal to 0 in equation 9, we have y of x comma t, c4 0 हो गया, so it will to c2 into c3 sin k by cx into cos of kt. This is the solution. ये हमको मिला. This will be the equation number. This will be the equation number 11. Now we substitute the last initial condition, that is the y is equal to k Lx minus of x square. One thing's more in this part, since in the given initial condition k is given, so we cannot consider this and we modify this k square we taken as p. So जहाँ हमने ये k लिया था वहाँ हम इसको p लेट कर लेंगे. दिस विल बी p. हर जगह p हो जाएगा क्योंकि k ऑलरेडी गिवन है, तो इसको हम उससे डिफरेंट लेंगे बाय मिस्टेक. दैट इज़ द we have not considered it at that time. So here will be p. This is also p and p. This is p. This is p. This is p. This is p. And it will be also p हो जाएगा. ये भी p हो जाएगा. p and in that case this be also p. This be p. This be p. ये नोटेशन हमको चेंज इसलिए करना पड़ा क्योंकि हम जनरली के स्क्वायर लेके चलते थे, सोल्यूशन हमको मिल जाता था, बट इन द गिवन इनिशियल कंडीशन दैट इज़ इन द फॉर्म ऑफ के, सो वी टेक इट डिफरेंट and we take it k Lx minus x square is the initial condition when t equal to 0. Now put this in equation 11. We have k of Lx minus x square, this be c2 c3 sin of p by cx into cos of 0. So this will be c2 c3 sin of p by cx. This will be k Lx minus x square. Now think about this equation. This is same as Fourier sine series. This is same as Fourier sine series. Fourier sine series. सो फूरियर साइन सीरीज़ में जब हम चलते हैं तो एक चीज़ ध्यान रखिएगा कि ये जो आपका समेशन है, जो ये कांस्टेंट है, वो समेशन में लिखा जाता है. यदि आपको याद होगा तो फूरियर सीरीज़ एफ एक्स इज इक्वल टू ए नॉट बाई 2 प्लस समेशन ऑफ ए एन कॉस एन एक्स प्लस समेशन ऑफ बी एन साइन एन एक्स. सो सब कुछ उसी तरह का है. सो हम इसको लिख सकते हैं कि दिस इम्प्लाइज दैट के टाइम्स एल एक्स माइनस एक्स स्क्वायर, दिस भी द समेशन एन इक्वल टू 1 टू इन्फिनिटी, क्योंकि ज़ीरो पर ही ए नॉट होता है, एंड दैट इज़ द बी एन साइन ऑफ पी. पी की वैल्यू होती है, पी की वैल्यू आपने कैलकुलेट किया है एन पाई सी बाई एल, तो सी भी कैंसिल, एन पाई बाई एल into x. So this equation can be written in this form in case of Fourier series, and Now by using Fourier sine series, we have Bn is equal to 2 upon L integration from 0 to L k of Lx minus x square sine of n pi x by L dx. Now we integrate this equation. We have this be equal to 2 k by L. K is the constant, बाहर हो गया. फर्स्ट फंक्शन तो Lx minus x square first function into minus of integration of sine, that is cos of n pi x by L, and this be L upon n pi minus of differentiation of this L minus x 2x L minus 2x into minus of cos n pi by L x into L upon n pi dx, and limit of the integration is 0 to L. So this can be written as this be equal to 2k by L Lx minus of x square, minus sign will be common, this be L upon n pi cos of n pi x by L, and minus will be plus integration L minus 2x L upon n pi will be common, sine of cos of n pi by L x dx 0 to L. The last equation we write in this form. So this will be equal to 2k upon L, this will be minus Lx minus of x square L upon n pi cos of n pi x by L plus L upon n pi, and now we integrate it L minus 2x into cos का integration, so sine of n pi by L into L upon n pi, फिर minus integration of, and this term differentiation of this term is minus of 2 into sine of n pi by L into x into L upon n pi dx 0 to L. So this will be equal to 2k upon L minus of Lx minus of x square L upon n pi cos of n pi x by L n pi x by L minus of plus of L upon n pi यहाँ पर भी है, L upon n pi यहाँ पर भी है, तो ये हो जाएगा L स्क्वायर अपॉन n pi L स्क्वायर अपॉन n स्क्वायर पाई स्क्वायर L minus 2x into sine of n pi by L, and minus will be plus, minus will be plus 2 times L square upon n square pi square integration of sine of n pi x by L dx 0 to L. Now we integrate one more times 2k by L minus of Lx minus x square L upon n pi cos of n pi x by L plus of L square upon n square pi square L minus 2x into sine of n pi by L plus of माइनस हो जाएगा 2 टाइम्स L क्यूब अपॉन n स्क्वायर पाई स्क्वायर cos of n pi x by L and limit 0 to L. This. Now we substitute the initial condition. So when we substitute L, the L square, this will be 0. When we substitute the initial condition 2k by L, we have L, it will be 0. It will be 0. Clear hai? And when we substitute here, so n pi x sine 0 is 0, sine 0 is 0, alright, plus 0. When we substitute here, it will be exist minus 2 times L cube upon n cube pi cube n cube pi cube. And now when we substitute 0, so x equal to 0, this will be again 0. So finished it, minus 0 plus 0 and फिर minus sine 0, again it will be 0, and this minus plus into one more things, sorry, this will be into cos of n pi and minus plus 2L cube upon n cube pi cube. This is the complete solution, and this can be written as this be equal to 2k by L minus of 1 to power n हो जाएगा n pi when positive negative, so minus of n 2 times L cube upon n cube pi cube and plus of 2L cube upon n cube pi cube. So this will be this bn is equal to when we taken n is positive even number, so it will be 0, and when will we take it odd, so this will be 0 when n is even, and this will be 8 L square k upon L से कैंसिल हो गया n cube pi cube when n is odd. So putting the value of bn in equation, in equation 11 can also be written as summation of n equal to 1 to infinity bn sine of p by cx cos of pt. This will be same as in equation 11. When we substitute the value of Vn in equation, so when we put value of Vn in equation 11, we have this y x comma t. This will be summation of n equal to 1 to infinity 8 L square k upon n cube pi cube sine of n pi x by L into cos of n pi c by L into t for n is odd. This solution will not for the all value of n, but this is the value of only for the value of n is odd. N is odd. So this is the complete solution of the given wave equation. So in this way we can find the solution of the wave equation which is given in this page number. This be the here del 2y over del t square equal to minus of equal to c square del 2y upon del x square. इसका ये आपका solution हुआ. This be the complete solution. So in this way we can find the solution of given wave equation. In next video we meet with another example.